Okay, fearless team Fliegelschnurz. Are you ready to go with section 2.4, which is distances on the number line, which we enjoyed so very much on this past time that we met. But first, let me see what it is that I want to say. Today's been a long day of videotaping. What adjective would you use to describe a mean, dangerous, grouchy, dastardly pig? Well, he would be very dispigable now, wouldn't he? So, I want to go ahead and girls, go ahead and get out a piece of paper and write down these definitions, because what we're going to have to be doing is creating some absolute value equations to solve some of the word problems, and this is something that we haven't done up to this point. And really, if you will write down definitions and just learn, the more you use it, the more it will make sense. I'm still sort of chewing on the actual way that you work these out myself. First, if you have the absolute value of x is equal to 5, we know that absolute value, just all in and of itself, means the distance from 0, that it can be the distance from 0 in the positive direction on the number line. It can be the distance from 0 in the negative direction on the number line. This right here just says that some point x is 5 units from 0 on the number line. And that's absolute value at its most basic. That's what we've been working with. That's what we're comfortable with. It's when we end up with strange critters like this, the absolute value of x minus 1 is equal to 4, that we have the location of our positive and our negative points are not co-equal from 0. They're not the same distance from 0. And that's because when you have this minus the number inside the absolute value bar, what this actually says, this means that the distance from some point x to a positive one is 4 units. This one right here, the absolute value of x plus 1 is equal to 4, means that the distance from some point x to negative 1 is 4 units. What I want you to specifically write down, I don't think you need to write that down. You know that this says the distance from x, the distance of the point x from 0 is 5. You know what that is. That just means some point x is 5 units from 0. Go ahead and take the time, write down these two, and get used to saying, reading it this way. The distance from x to positive 1 is 4. The distance from x to a positive 1 is 4. The distance from x to a negative 1 is 4. Say it this way, it's not the distance from x to 4 is a negative 1. It's the distance from some point x to the opposite of this number is a negative 1. The distance from x to a negative 1 is 4. And this is what we're going to want to have memorized. The distance from some point x to this is this. Distance to is. So if you remember that, distance from this to this is that. That's how you're going to be setting up these absolute value puppies that we're working with. So, let me go ahead and erase that. And I think I want to walk over here and zoom this in just a little bit. Gives me the teeniest bit of a chance of being able to actually see what's going on the screen. Okay, it could be more, but we'll live with this. Okay, I want to go back through just a quick review. Solving for distance on the number line. You guys picked this one up right away. On Tuesday, if you have 2x, absolute value of 2x plus 2 is equal to a negative 6, do you need to go ahead? 20. Do you need to go ahead and break this down into two equations? Well, no, because his distance Is absolute value ever negative? No, absolute value is never negative. So you can immediately say that there's no solution if you have the only thing on the left-hand side of the equation or on the right-hand side. But on the left-hand side of the equation is just the absolute value bars set equal to a negative number, and then there is no solution. If, however, you had the absolute value of 2x plus 2 minus 7 is equal to a negative 6, you would not want to go ahead and say immediately that this has no solution because it's set equal to a negative 6, because you have to isolate that absolute value quantity, that absolute value expression itself, all on its own on the left-hand side. We're going to have to add a positive 7 to both sides of the equation, which will give us a positive 1, and the equation can be solved then. Next thing to remember is, how do you find the midpoint of two numbers? The midpoint of a segment joining negative 3 and 11, the way that you find the midpoint is you add the two numbers together and you divide it by 2. How's that for a nonsensical scrawl? It sort of looks like a smiling worm type face or something. Let me put this legibly for you. If we want to find the midpoint between negative 3 and 11 on the number line, you add the 2 points and then you divide them by 2. Negative 3 plus 11 is 8. 8 divided by 2 is 4. So the midpoint between negative 3 and 11 on the number line is going to be the point positive 4. And we'll just think about this. See, from negative 3 to 0 is 3, plus 11 is 14. So there should be 7 units to the left, 7 units to the right. Well, from negative 3 to 0 is 3, and then on the 4 is 7 units. From 4 on the number line to 11 is 7 units as well. So you see that 4 truly is the midpoint between negative 3 and a positive 11. Okay, distance and absolute value. The distance formula for number lines, so if you have 2 points on a number line, negative 8 and, well, let's just go ahead and do that same one, negative 3 and 11. And we already said that the distance between those 2 points was a 14, and we did it. Can you see that up there? I can't tell. And we did that by thinking, okay, here's negative 3. Negative 3 to 0 is 3 units, and from 0 to 11 is 11 units, which gives us a distance of 14 units between those 2 points. So, if you're trying to find the distance between two numbers on the number line, it's always absolute value. Distance is equal to the absolute value of their difference. It doesn't matter which one of those points you put first. Doesn't matter if you have the smaller number or the larger number first. Positive 11 minus a negative 3. Distance is the absolute value of 14, and of course, both times you get the same. Solution, because absolute value is always positive. So, if you want to find the midpoint, you add the two numbers together and divide in half. You want to find the distance. What you're doing is finding the absolute value of their difference. The order in which you write those two numbers doesn't matter at all. So we found the distance between the coordinates with points -3 and 11. And that was example 3. Now, let's look at example 4. This says, write an absolute value equation for the graph. Example 4, page 55. This one, I'm having a little bit of difficulty getting some good words to describe it, so I'm going to step you through what you do, show you the words to say. And you're going to be practicing these in section 2.4. This says, write an absolute value equation for this graph. Write an absolute value equation for this graph. And this is the graph that we have. We have -1 and we have 3. There's 3 and there's -1. Now, absolute value, as we've been using it, is the distance from 0. But here, if we're going to use absolute value, we're just going to use it as the distance from a common point. Now, obviously, it's not going to be the distance from 0, because we have a distance from 0 in the negative direction of 1 unit. And we have a distance from 0 in the positive direction of 3 units. So that's where we're going to use those two equations, the ones that we had here, the black one and the blue one. The absolute value of x plus 1 is equal to 4. Absolute value of x minus 1 is equal to 4. And what we said was the distance from x to a -1, where the sign changes were different, was equal to a 4. What we're going to do is we're going to, in a manner of speaking, we're going to create our own 0. That line right there is going to represent our own 0, if you will. And what do I mean by a 0? And see, God is telling me right now how to make this make more sense to you, and I hope it comes through. When we make our own 0, we're figuring the number, we're coming up with an adjustment here so that the distance from this number that we've come up with in the positive direction is the same as the distance in the negative direction. So it's not 0. Obviously it's not 0, and this one here is going to be 1, because if we move it to 1, from 1 to 3 is 2 units, and from 1 to a -1 is 2 units in the opposite direction. So it's like absolute value. It's the absolute value from this point, if you will, whatever this point is here. And what is this point actually of this distance? Well, if you have this piece of cord right here from my headphones, let me stick my headphones around my neck. And let's say I have this length of cord right here, and I come up with something that is like our own artificial 0 right here, where the distance from this to this hand is the same as this distance. That's like saying the absolute value from this point here, because the absolute value is the distance from 0. The absolute value of 4 is 4 units from 0. Absolute value of -4 is 4, because it's 4 units from 0. Well, what have I done here? This was my cord that I began with. And to make the distance be the same, this is in half, isn't it? This point right here, where I'm holding the cord, that's the midpoint. So what we're doing with these equations then is, when we write an absolute value equation for this graph, we have to create our own 0. In other words, we have to find the midpoint, and then we're going to create our absolute value equation based on this midpoint here, okay? So let's see what we're going to end up with. Let me redraw this. We have this line. It's at -1, -3, and there's 0. -1 is the point, -3 is the point. What's our midpoint going to be, or actually what's our distance going to be? The distance between the 2 points on the number line, distance is the absolute value of 3 minus a -1, or the absolute value of -1 minus 3. 3 minus -1 is 4. -1 minus 3 is -4. The distance between these 2 points is 4. And you can see that's clearly through. -1 to 0 is 1. 1 to 3 is 4. This is our distance. Now, we want to find what our midpoint is. What's the midpoint of these two locations on the number line? Well, you have -1 plus 3 for the midpoint. Hopefully you can, I'll just sketch this over here, -1, 3, 0. The midpoint is 3 plus a -1 divided by 2. And the midpoint is going to be located right there. That's our midpoint, okay? Now what we want to do is find the distance from either end to the midpoint. So what we're talking about, the distance from either end to the midpoint, that's going to be 2 units, isn't it? Three minus the midpoint has to be, this distance here is 2 units. And I showed you the distance between all of them has to be 4. Obviously, the distance is 2 units. So what we have now is the distance from this original point x, the distance from x to the midpoint, which is a +1, is equal to 2. Absolute value is the distance from 0. Absolute value, this is the midpoint right here, the midpoint of this line segment is going to be 2 in the right direction, 2 in the left direction. So remember our definition that we set up, and I'm still struggling for this. You know, I got some good clarity on the first part of it, but this is the distance from any number, you know, distance from the number to +1, which is our midpoint, which is our 0. The distance from a number to 1 is 2. That's our absolute value. That's our distance. From this point right here on the number line, this says what this equation means is this silly little picture here. The distance from a +1, the absolute value is 2. This distance, or the absolute value, from here to the end points of our line segment, from a midpoint to the end point of the line segment in the positive direction, to the end point of the line segment in a negative direction, that distance is going to be 2. So, an absolute value equation for this graph, absolute value x minus 1 is equal to 2. Now let's go do another one that is, where we just go right through it in order. We have, if the point represented, this is number 5, example 5, page 95, if the point represented by x is 5 units away from the point with a coordinate of 3, find all possible values of x. Okay, here's a point, x, and it is 5 units away from the point with a coordinate of 3. This is, okay, it's 5 units away from here. Now, you notice that I have x going 5 units towards the left. Does the problem say that? No. The problem says the distance from x to 3 is 5 units. That's alphabetical. That is absolute value, isn't it? So x could be either here, or x could be 5 units in the opposite direction. Because that's what absolute value really is. It's the distance from something. 2 ways. Positive direction, negative direction. So what this means, remember, we said the distance from x to 3 is 5. The distance from x, we have this positive number here, so that becomes x minus 3 is 5. They're saying when you have this expression inside the absolute value bars, that what this means is the distance from some point x to a positive 3 is 5 units. If this were a negative 3, how would it change? This is how it would change. The distance from some point x to a negative 3 is 5 units. The signs here are opposite. This is just a pattern that you have to learn. I hate it when I say just learn the pattern, because I don't think it's the best way to do things. But there were many, many times in various different math classes that I've taken, and science classes, where it's like, why is it this way? Well, because this is the pattern. Why do we distribute? Because this is how you do it. This translates into the distance from some point to a negative 3 is 5. Okay? Let's go ahead and see what else we have here. Well, that's the end of the examples. Let's do number 14. Number 14. And this says a certain number is 4 units from 9. Okay, a certain number is 4 units from 9. So here we have 9. The number can be here, or the number can be here. The distance of some number x is 4 units from 9. You know, it could be 13, or it could be 5. So how are we going to set this up? Well, we're going to remember our blah, 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 blah. our definition that we just wrote. The distance, absolute value, from some number to a positive 9 is 4. Does this work? Let's solve it. X minus 9 is equal to 4, or x minus 9 is equal to a negative 4. Plus 9, x is equal to 13, plus 9, x is equal to 5. Get the pattern down. The distance from some number to 9 is 4. The distance part of it goes over to the right of the equal sign. The distance from some number to a positive 9 is 4. Let's go ahead and do another problem. Okay, let's look at number 16. If 5 is 4 units from a certain number, here's our certain number. 5 is 4 units. This is number 16 on page 56, which you were not assigned. If some number is 4 units, well, let me read this the way it says it. If 5 is 4 units from a certain number, what is the number? So it can be either here or it can be here. What are our number values going to be? They're going to be 1 and 9, aren't they? But they don't want to know what the numbers are. They want you to translate it into an equation, and it says, if 5 is 4 units from a certain number, what is the number? So what you say is the distance from a number to 5 is 4. Remember that equals translates into is. So let's solve this equation here. Remove the absolute value brackets, keep the equation as it is, or you remove the absolute value brackets and set it equal to the negative. X is equal to 5, that's not true. X is equal to 5 plus 4, which is 9. Or x is equal to negative 4 plus 5. X is equal to 1, which is exactly what we showed these to do, what we calculated the values to be. And it was borne out here when we solved the resulting absolute value equation. This says the distance from some number to 5 is 4. Okay? This is from some number. If we had the distance from 0, what would you have? Hey, that just made a lot of sense to me. This says the distance from 5 is 4. This says the distance from 0 is 4, which is the absolute value of x. The distance from 0 is 4. The distance from 5 is 4. So this is another connecting piece here. Play with these, do the problems, work on them. I know you've got a lot going on, but you can do it. I've got confidence in you. Go Team Fliegelschnorz. And by the way, when you make those t-shirts, I'll make